So for question 9, given that our polynomial is a cubic, so when you can see the x power of 3 means this is a cubic polynomial, and it said it has a factor. So when it said it has a factor, means this is our factor theorem. Our polynomial will equals to 0 because the keyword is factor, means no more remainder will left behind when it divide by x plus 1. So our x value here is equals to -1. So we can use our factor theorem. Therefore, our theorem here will be writing as p, substitute the value of -1, then we will get 0. So from here, we have to find out our q in terms of p, means let the q as a subject. Q equals to something p. So we substitute our -1 here, we get negative p. Continue. Here we get p plus q. Then we substitute here -1 will become negative p plus negative 2q, then plus 1 equals to 0. So we let the q at left hand side and then p to the right hand side so that we can get the q as a subject. So our q here we get negative, and then what is our p? So we can see p here can be simplified. Plus p minus p we can simplify. Then we leaving one p, so that p will move to the right hand side. Move this to the right hand side and move the 1 to the right hand side, it will become p minus 1. So finally, q is equals to 1 minus p. Okay? Times that, divide by negative. So I put the positive value at the front here. So 1 minus p. So from here, this is our factor theorem. So writing this factor theorem correctly, we will get 1 mark. This is our basic. Then only we apply the concept of substitution to get to the answer that asks for us q in terms of p. So for question B, they want us to write the fx in terms of p and x. Means original, our polynomial is px. But now they want to represent it in terms of p and x only. They don't want the term of q. So writing in fx. So now my new labeling will be using fx, which is a polynomial involving px only, involving this unknown p and x. And then after that, we have to determine the quotient of this polynomial fx divided by x plus 1. So from the original polynomial we have px is equals to px cubed plus p plus q x squared plus p plus 2q x plus 1. So now they want to change it to fx, which is they maintain the p and x only. So the q part, for the q part, we are going to substitute it as 1 minus p. So this p will maintain. For the q, it will substitute by 1 minus p. Okay, so we simplify our polynomial here, where p minus p will be finished, we get 0. So here leaving a x squared. How about here? P plus negative 2p. So it will getting negative p and then plus 2x. So this is our new function, which is fx, new polynomial, which is fx, in terms of p only. So then, after we finish this first task, we're going to find out the quotient. So if we want to find out the quotient, we need our long division. divided by x plus 1. Divided by x plus 1. So how to get the multiplier? So how to get the multiplier here? So we can go for one by one. We divide back so that we know what to multiply here. So the constant here is p. The constant here is 1. So p divide 1, I need a multiplier p. Meanwhile for x cubed divided by x, so I need a multiplier of x squared. And then we expand back, we multiply back so that p times 1 became p, x squared times x, we get x cubed. So we expand for the following terms also. P times 1, we get p. And then x squared times 1, we get x squared. So we find out what is our remainder here. So p minus p is 0. Here will be our coefficient 1 minus p. 1. Our remainder here will be 1 minus p. So we don't have any value, so we maintain it as a p terms here. We deal with the unknown p. We will repeat finding the multiplier for this division. So multiplier here, you can see 1 minus p. I want to get this 1 minus p. So this is value of 1. So therefore, multiplier here is 1 minus p and then another x. Because x squared divided by x, I need another x. Then we expand back. So constant times with 1, it will be 1 minus p constant x squared. X times x, we get x squared. So expand for the following. 1 minus p times 1, it will become 1 minus px. Then we minus. So for this division, it is done. Then we minus. So 2 minus 1, we get 1. P minus negative p, so we get 1x. So continue, drag down the 1 because here is 0, 1 minus 0, that will 1. So you can see I need a 1 here. In order 1 times x plus 1, we are getting x plus 1. So no remainder here. So what is our quotient? Quotient is this part. So answering the question, quotient of this division is equals to px squared 1 minus px plus 1. So this is the fx that we get in terms of p only, p and x, then a concept of long division to get to the quotient. So we continue to our part C. They say hence find the value of p if x is equals to 3 is one of the roots for this function polynomial fx equals to 0. Hence, use the value of p, factorize this polynomial completely. So they say x is one of the roots. So when x is one of the roots, indirectly they want to tell you means x minus 3 is one of the factor. Because from the factor, then only we can get the roots. So when they say x equals to 3 is one of the roots for this polynomial, so means that my polynomial have one of the roots, which is x minus 3. So we can use our factor theorem to find out what is our p here. So we substitute x equals to 3 into our polynomial here, it will get 0. because it is our roots, it is our factor, so we will have equals to 0. Then we substitute 3 into our fx. 3 here. Or in other words, if you don't want to find from here, in other words, we also can find from here, because you can see this is one of the factor, right? Okay, so I can write it clearly for you like this. Let me show you before I substitute here. Our polynomial fx, where one of the factor is x plus 1. Another of the quotient is px squared plus 1 minus px plus 1. So reminder don't have. You can see reminder don't have. When a fx divide by our divisor, quotient is this. So our divisor, we multiply it, we write in the term of one sentence here. So fx will be divisor, and then this is our quotient plus reminder. So not necessarily we have to substitute back here. So we can use the expanded form, or we can use its factorized form. So from we can see here, I will use a factorized form here for us easier to calculate. Of course, you want to substitute back into this fx also can. So when x equals to 3, it is our factor. So I will substitute back here. So 3 plus 1 will equals to 4. And then this one, 3 squared will equals to 9. And then here, times 3 plus 1 equals to 0. Then we can simplify it. 9p plus 3 minus 3p plus 1 equals to 0. I move the 4 to the right hand side so that it will equal to 0. Then we manage to find this one. P is 6p equals to negative 4. So p is equals to negative 2 over 3. So finally, we get our function. If in expanded form here, here is our negative 2 over 3 x cubed plus x squared, and then plus 8 over 3x plus 1. Alright, so I use the expanded form because I want to factorize it completely after that. So this is our p. Finish the first task, find the value of p, and then using this p value, factorize it completely. So our factorized form at here, so also we can substitute x plus 1. Now our p is negative 2 over 3x squared. This is our factorized form. So factorize it completely. We can see quadratic here. We factorize it completely. So we can take out the fraction. We can take out the fraction. Let's say this fraction is 1 over 3, right? So we take out this negative 1 over 3 so that our quadratic will be in positive. Then only we can factorize it easily. So 2x, x, so this one is 3, this one is 1, minus Then should be positive, right? This is 2x plus 1. This is x minus 3. Then only can go back to the quadratic. 1 negative 3, yes. Then negative 6 plus 5, yes. So this is our form of factorize it completely. So what is important here? First, our method to find out our p, and then we substitute our p here to do the factorize completely answer.